All right. So hopefully you've already watched the first video on finding the asymptotes. This right here is a general rule that I would take in graphing a rational function. So I would say there are four things you want to look out for. So there are four things you want to look out for. And in order, the first thing that I would look out for, number one, are the x-intercepts. So I might want to find the x-intercepts first. Number two, the y-intercepts. Reason I say these guys might be first is they're going to do some things on the function, excuse me, that might be helpful to us. Number three, I'm going to want to find my vertical asymptotes, so the vert asymptotes. And then finally, I'm going to want to find my horizontal asymptotes. After that, I'm going to have a setup of what I'm going to do. I'll have actually a structure for it so that I can go about graphing the rest of it. But these are the main pieces that I want to find: x-intercepts, y-intercepts, vertical asymptotes, horizontal asymptotes. Now the nice thing is that there's parity of all of these things right here. So for the x-intercepts, set the top equal to 0. So I don't mean make x 0, I mean set the numerator equal to 0. So for the x-intercepts, I'm going to set the numerator equal to 0. For my y-intercepts, I'm going to plug 0 in. Okay, so I'll plug 0 in. For my vertical asymptotes, what I want to do is I want to set the denominator equal to 0 after I've simplified the function. Now this function here, I'm going to rewrite it, this fraction, I'm going to rewrite it as x over, factor it out to x plus 4 times x minus 2. And you'll notice that nothing's going to cancel out. Now if I go back to my notes on vertical asymptotes and horizontal asymptotes, since nothing cancels out, my vertical asymptotes are going to be based off the denominator. So based off the denominator, I can already say that x equals negative 4 and x equals 2. So my vertical asymptotes are when x equals negative 4 and when x equals 2. Next, the horizontal asymptotes. Since the numerator has a degree that is larger than the denominator, right, the degree 1 on the top, degree 2 on the bottom, this automatically means that the horizontal asymptote is 0. So I have a horizontal asymptote at y equals 0. Okay, so that takes care of the asymptotes. I know I said I was going to do the x-intercepts, y-intercepts first, but the asymptotes, after you simplify it, kind of makes sense to do that. Next, the x-intercept. The x-intercept is when you set the numerator equal to 0. So if I set the numerator equal to 0, what I end up getting is x equals 0. So I end up getting x equals 0 as my x-intercept. And then my y-intercept is when I set x is equal to 0. So if I plug a 0 in here, I get 0, 0 squared, 2 times 0. And that's going to give me 0 over 0 plus 0 minus 8, which comes out to just 0. So my y-intercept is going to be y equals 0. Now, after I establish that, one of the things I like to do is I like to make a t-chart. Now, not the normal t-chart that's vertical, but a t-chart that's horizontal. This horizontal t-chart is going to give me a better understanding of what my graph looks like because it mimics my x-axis. So it's going to mimic the x-axis because it's in the same direction as the x-axis. Things that I'm going to want to make sure I understand first or monitor or write down first are going to be my vertical asymptotes. So I want to make sure my vertical asymptotes are well established on my graph. So I'm going to put negative 4. Oh, sorry, that's not what I meant. I'm going to put negative 4 right here. So I'll put a negative 4. And then I'll block this guy off. Now when I plug negative 4 into the function, it's undefined. Okay, so it's undefined over there. Also, I'm going to talk about 2. So I'm going to have 2 blocked off. 2 is also undefined. Okay, those are the first two things I want to make sure I have. Now, what I need between them are just a bunch of points. I don't need a ton of points, I just need a few. Finally, the horizontal asymptotes. The horizontal asymptotes are defined by this guy. Now this guy means that if I was to plug in really big numbers, okay, so gigantic numbers, really big numbers, I'm going to approach 0. I'm not going to equal 0, but I'm going to approach 0. In class, I call that 0-ish. So you're going to be kind of like 0. Not really, you're going to be like 0.1, 0.01, 0.001, 0-ish. And the same thing is true over here on this side. Definition of the horizontal asymptote is that as you plug in super big numbers, right, as you approach infinity, what's going to happen is your y value is going to approach 0. So it's going to be 0-ish over here. So that's going to be our horizontal asymptote. So making sure that we understand what's going on, I've taken care of the horizontal asymptote and I've taken care of the vertical asymptote. Next, now I want to go through the problem and identify all my x-intercepts if I have multiple x-intercepts or my y-intercepts. I have a single x-intercept at 0. So I have a point at 0, 0. Now my x-intercept and y-intercept are exactly the same here, or it is the same here. The reason why is because it was at the origin. So this right here is going to give me another point. Now, between my undefined, between my asymptotes, my x-intercepts, I need to find other values. So I now want to plug other numbers in. These numbers right here are up to you. You can plug anything you want in. So step one, make sure you understand all of this right here. So if you're taking a look at what we did, we took a look at our asymptotes, we plotted them out, then we took, sorry about that, we took our x-intercept and our y-intercept and we plugged those in. Now the reason why I have the asymptotes in red is because those are points we're not going to actually be able to attain or touch, and then the stuff in blue are things that are actual points. Now everything else are going to be points that we haven't defined yet, that we get to pick. So what I'm going to do is I'm going to pick a number between 0 and -4. For example, -1. Then I'm going to pick a number between 0 and 2. Sorry, that kind of looks bad, so change the color on that. -1, and then a number between 0 and 2. 1 would be a good number. And then I want to pick something after 2. So I want to make sure that I have something between every single marker. The markers being the asymptotes. And then over here I'll probably pick 3. And over here I'll probably pick -5. That should give me enough information on how to graph this thing. So now I plug in, I'll start with 3. So I'm going to get 3 over 7, and then 3 minus 2 is 1, so 3 over 7. So over here I'm going to get something like 0.4, let's say. All right, next, it doesn't have to be super accurate. You just need to have a basic understanding. If you want to write the fraction 3/7, by all means, write the fraction 3/7. Next, plug in 1. So I put 1 in. That's going to give me 1 over 5, and then -1, so -1/5. So over here, we're going to hit -0.2, or -1/5. Next, plug in -1. When I plug in -1, this is going to give me -1, 3, and -3. So -1, 3, and -3. You'll notice that I have 2 negatives, which means I'm going to have a positive, and 3 times 3 is 9. So this guy here is going to be 1/9, or 0.1, just 0.1. I was going to say 0.1111, but 0.1 works. That's just as good. Next, plug in -5. So when I plug in -5, I get -5 on the top, I get -1, and then I get -7. So I get a negative, and a negative. 3 negatives gives me a negative, so I get -5/7. Also, I could write that probably close to -0.57. Let's go with 0.6. It's probably 0.7 or something like that, but 0.6 works well as well. It's close enough. All right, now that you have this, what you want to do is you want to set up your x-axis and y-axis. Now we're just doing a rough sketch. This sketch is actually pretty accurate. What I mean by that is the asymptotes alone are going to give you a fairly accurate representation of what you're graphing. So the first thing I'm going to do is graph my asymptotes. So I know I have a horizontal asymptote at 0. So I'm going to start with my horizontal asymptote at 0. I'm talking about y equals 0. So we got this guy, that dotted line down there. All right. And then after you get your horizontal asymptote, it might be a good idea to graph your vertical asymptote. So I'm going to go over to 2, 1, 2. I'm going to draw my vertical asymptotes right there. All right, so, and then go over 4, 1, 2, 3, 4, and we have our second vertical asymptote. After you have your vertical asymptotes, I would graph your x-intercepts and your y-intercepts. Now, since the x-intercepts and the y-intercepts are exactly the same, it's this guy right here, we're going to plot just that single point. Now, this is where I get a lot of confusion. A lot of students say, but you're not allowed to cross the asymptote. That's not the definition of the asymptote. It has nothing to do with what happens down here in the small numbers. The asymptote is defined by what happens on the really, really, really big numbers, right? That's the reason why it was 0-ish. Not anything to do with what happens in the middle of the graph, but what happens at the extreme ends of the graph. All right, next. Now I'm going to plot all those extra points that we have. So the first point that I have is going to be at 3.4. So 1, 2, 3, and then up to 0.4. So I'm going to get a point right there. Now what I need us to do is I need us to understand what this tells me about my graph. As I approach the graph from this way, I know I have 2 options. I can either choose to go up or I can choose to go down. If I go down, I will have to cross the x-axis, which means I'd have an x-intercept. The problem is I only have one x-intercept and it's right there, which tells me the graph can't go down. In fact, it must go up. So what I'll do is I'll make sure my graph goes up towards the asymptote using the definition of the asymptote. Now, since my graph can go this way, it can either go up in the air or it can follow the asymptote. And because the definition of the asymptote is that really big numbers, it approaches the asymptote, I'm going to try to get closer and closer to the asymptote. This is why I graphed this first piece, or how I graph the first piece here. Next, I'm going to graph 1, -2. So now I go over 1 down to 0.2. That gives me a point right here. Now I know that on the graph it's going to go this way because that's the definition of the asymptote. Also, I know it can't go this way for the same exact reason from the previous problem. It would have to cross the x-axis, and there are no x-intercepts between that point to the asymptote. So graphing it up doesn't make sense. Graphing it down does. Now, I need to connect this point to this point because that's what they are. So I'm going to connect the points, that's what they are, because it's a continuous function between there to there. So I know it's continuous because the asymptotes aren't between them, so I know it has to connect to that. And then I'm going to graph this guy here at negative 1.1, so negative 1.1, which gives me a point here. Now I know the blue dot, the x-intercept, the y-intercept, is going to connect to that guy. So I do have a connected graph. And then the question is, what am I going to do as I approach? Am I going to do that, or am I going to go up? Now, if I go down, that means I'm going to have another x-intercept, which is not allowed because I only have one x-intercept, which tells me my graph is going to approach, and then it's going to go up like this. So it kind of looks like it's a cubic function between these two asymptotes in this problem. And then finally, I'm going to graph my last value, which is at negative 5, comma, negative 0.6. So negative 5, comma, negative 0.6 would give me a value somewhere around there. Now I know that my graph is going to approach the asymptote this way, because as I approach a really big negative number, I'm going to get something close to 0. And then I have to go through the same scenario. Is my graph going to go down, or is my graph going to go up? Now remember, if the graph goes up, it would have to cross the x-axis, which is not allowed because I only have one x-intercept. So going in that direction, doesn't make sense. So what we're going to do is we're going to graph the graph this way. All right, so to sum it up, the first thing I need you guys to do, make sure you find these guys here. The second thing, plot the red and the blue. The red being your asymptotes, the blue being your x-intercepts. Then between your asymptotes and your x-intercepts, you get to pick values that determine how your graph is going to be situated. And after you do that, you should have your graph. Please take a look at the assignment and have a good day.